Okay, welcome back to part 2 of the supplementary review worksheet solutions. So I've just finished the factoring of this using the box method. I'll use the method that I've taught in previous classes when I do a later quadratic. So let's jump ahead and move on. So again, you'll see highlighted in here, of course, is the instruction that you are not to use the TI Inspire because we won't be using it on the test. So we've been asked to find the values of x and y that will make M, P, N, O a parallelogram. In order for it to be a parallelogram, the diagonals would have to bisect each other, and so we're going to find the values of x and y that will cause that to be true. So our equation x plus y is equal to 2x minus 3. And so what I'm going to do straight away is I'm just going to simplify that equation a little bit. I'm going to move the x to the right-hand side. So y is equal to x minus 3. So I'm subtracting x from both sides to get y equals x minus 3. There's my first equation in a very usable form. And then what I'm going to do is I have my second equation over here, which is going to be 2x equal to 5y. And so those are my two equations. I'm going to solve this using substitution. And so what I'm going to do is in the place of y, I'm going to substitute in x minus 3 because y is equal to x minus 3, and that's going to allow me to solve the equation. So I'll then have an equation which says 2x is equal to 5 times x minus 3, and I've now eliminated the y and I've managed to get the equation with just x's, and I can now go ahead and solve. So we have 2x equals 5x minus 15. Move the 5x to the left hand side. Minus 3x is equal to minus 15. Divide through by minus 3, and we're going to get x is equal to 5. We can then substitute that value back in over here because we know that y is equal to x minus 3, and therefore y must equal 5 minus 3 because x is equal to 5, and we get y equal to 2. And we've now solved our system of equations with x equal to 5 and y equal to 2. And that was done by substitution. Okay, moving on to the next one. So the instruction here, find the lengths of the sides of RTSU. Once again, we won't use our TI Inspire. And what we have been asked to do as well is to classify it with the most accurate name. So after we've solved, we'll sub back in, we'll figure out how what the lengths of the sides are. Once we know what the lengths of the sides are, we will be able to classify this accordingly. Okay, so what we can already see, hopefully what you'll notice from the markings, is that we've already got ourselves a parallelogram by virtue of the fact that both pairs of opposite sides are parallel. And so what we're able to do is say that 2x plus 4 is equal to x squared minus 11 because opposite sides of a quadrilateral should be congruent. I'm going to start by moving everything to the right hand side, so x squared minus 2x minus 11 minus 4 is going to give me minus 15. From a factoring point of view, so you could use the box method at this point, the quadratic formula. What I'm going to do is just use a pair of binomials. So in order to get x squared, it's going to be x times x. The factors of 15, in order to get 15, it's going to be 15 multiplied by 1 or 5 multiplied by 3. I want the pair of factors that can add and subtract to give me minus 2. So that, of course, is going to be 5 and 3. The minus 15 tells me that the signs should be different. In order to get a minus 15, should be plus times a minus or a minus times a plus. And so now all I have to do is figure out which of these terms gets the minus and which gets the plus. In this case, since I have minus 2x as the middle term, I'm going to use minus 5 and plus 3, and that should give me x squared plus 3x minus 5x will leave me with minus 2x minus 15. That allows me to conclude that x is equal to 5 or minus 3. Final step would be to substitute those in and to see if either of these are extraneous solutions. So starting with x equals 5, that would result in a length of 14. If x is 5, that's going to result in a length of 14. If x is 5, that's 5 squared is 25 minus 11, which is 14. The alternative is minus 3. So I'm going to just change colors here for this. So if I sub in minus 3, I have 2 times minus 3, which is minus 6 plus 4, leaves me a length of minus 2. I don't need to go any further than that. That shows that the solution is in fact extraneous. Don't erase it, just cross it out and leave it as an algebraic possibility, but of course it's an unacceptable possibility because it produces negative lengths. That's not always true when it's negative, of course, but it is true in this particular case. And so x equals 5, we found the lengths of the sides as instructed, and the final part of the question is to classify. And so in this particular case, a parallelogram with congruent consecutive sides is, of course, a rhombus. And so we know for sure that it's a rhombus. We do not have enough information to ascertain whether or not it is a square or a rectangle and therefore a square. So rhombus is the correct answer. Okay, moving on. So we have to classify these using the most accurate name. Again, some of these are going to be pretty tricky, so pay careful attention to details. So what we have marked here are all of these angles congruent. If you notice that these three are within a triangle, that guarantees that they're 60 degrees each. Since they're 60 degrees each, of course, it guarantees that those three are congruent to each other. This is also 60 degrees, and 60 degrees. And so it guarantees that these three are equal to each other. What you have to be very careful of course, is whether or not this length over here is the same as this length over here. So just because they're both equilateral triangles doesn't mean their lengths are the same as each other. And so what we can do, though, is we can use that 60 degree with this 60 degree over here. And so we can prove that those two are parallel to each other. And at this point, even though it's tempting, we do not know anything else. There are no alternate interior angles for the other pair of sides. Like I said before, we cannot be sure that those two sides are equal to each other. So we could have an instance, of course, where we've got one small equilateral triangle, one large equilateral triangle, very badly drawn, but we would have parallel lines. But as you can see, I've tried to exaggerate this and draw two different sizes. We cannot be sure just by virtue of the angles that those triangles are congruent to each other. We have no information about sides, and therefore, being unable to rely on appearance, we must classify this as nothing more than a quadrilateral because we cannot be sure that it has any additional characteristics. Okay, moving on. Here we have two 90-degree angles. The two 90-degree angles mean that consecutive interior angles are in fact supplementary. This guarantees that the sides are parallel. Parallel sides, which are also congruent, guarantee that we have got a parallelogram. A parallelogram with a 90-degree angle allows us to conclude that this is in fact a rectangle. Okay, moving on to part C. So look very carefully. What we have is no alternate interior angles. What we have are base angles of the triangle, which are congruent. And so that's going to allow us to conclude that this side is going to be equal to this side. And I can mark it with a single marking because those two are congruent. Similarly, these two angles are congruent, and that means this side and this side are congruent. But since these two sides were originally given as congruent to each other, we can now ascertain, in fact, that all four sides are congruent. And since all four sides are congruent, this allows us to conclude that this is, in fact, a rhombus. Again, we do not know for sure if it's a square because we don't know if we have a 90-degree angle at all. And so all four sides of this figure are congruent, and therefore it is a rhombus. Okay, moving on to this diagram over here. We've been given two congruent sides. We've been given a congruent vertex angle, but we don't know how big it is. In other words, we don't know if it's 90 degrees or not. we have got a reflexive side. We are unable, however, to prove congruency of these two triangles because we have side and we do not have the included angle. So we have side angle, which of course does not prove congruency. The only exception to this, of course, was if this was a 90-degree angle. We don't know that. And once again, because we're unable to prove triangle congruency, we can conclude nothing further, and we must draw the conclusion that this is no more than a quadrilateral. Okay, moving on to finish off the worksheet. So let's just make sure we've got all of that done. So to finish off the worksheet, hopefully in the next 5 minutes, we've got a couple of proofs. So in this particular case, we've got our isosceles trapezoid ONKP, so KN parallel to PO, and our legs marked as congruent, KP and NO. And we've also been given parallelogram MLNK. So if it's parallelogram MLNK, then of course we've got, by definition, both pairs of opposite sides parallel. So I'm going to mark that on there. And what we've been asked to do is to prove that angle 1 and angle 2 are congruent to each other. So let's start with our isosceles trapezoid. First of all, if you know that it's an isosceles trapezoid, you should know that the base angles are going to be congruent to each other. And so we have got angle 1, and I'm going to put in angle 3. So angle 1 is equal to angle 3. You should also know, because we've got parallel lines, that we've got corresponding angles. So we've got our F from the fun rule, and this should allow us to conclude that angle 3 and angle 4, so I'm going to add in angle 4 there. Let me just mark that using a darker color. Angle 3 and angle 4 are going to be congruent to each other because of corresponding angles. And lastly, since we know that MLNK is a parallelogram, angle 4 and angle 2 are going to be congruent to each other because of opposite angles of a parallelogram. And so by the transitive rule, 2 equals 4, 4 equals 3, 3 equals 1, we're able to conclude that 1 and 2 are congruent to each other, and that is because of transitive. So what I'm going to do is, I've explained that. I'm just going to pause the video for a moment to write that up, and then I'll move on to the next example. Okay, so there we've got the proof written up. You can have a look at that if you need to. I'm going to try and move on to the next proof and wrap that up in the next couple of minutes. So I'll do the same quick explanation and then I'll write it up. Okay, so we've got WZ or Z equal to XY. We've got angle W and angle Y given as 90-degree angles. We've been asked to prove that WXYZ is a rectangle. You have got reflexive side ZX. And so what that should allow you to see is that we've got congruency of the two triangles by virtue of HL. So here's our hypotenuse and leg. With congruency of the triangles, we can show that WX is going to be congruent to ZY by CPCTC. This in turn gives us WXYZ is a parallelogram because we've proved that both pairs of opposite sides are congruent to each other. And so this allows us to conclude it's a parallelogram. We can then conclude that since it's a parallelogram with the 90-degree angle, it is in fact a rectangle. So that's the explanation, the sequence of the proof. And what I'm going to do now is just pause the video, write that up, and then you can take a look at that momentarily. Okay, and so there you see the proof written out, reflexive side, congruent triangles, CPCTC to give us our parallelogram, and finally the fact that we have a parallelogram with a 90, concluding that it is in fact a rectangle.